Find the stationary points and determine their nature. Given an equation like this one is we're going to apply partial differentiation. So we begin by finding the derivative with respect to different variables. So you start with dz dx. So with respect to x, this one becomes 2x, this one 0, this one plus y, this one plus 6, this one 0, this one 0. So that's derivative should be equated to 0, because we know at minimum point or maximum point or the stationary point, the derivative is equals to 0. So we also find for y, so dz dy. So in terms of y, this one will be 0, this one will be 2y. Then here we have x, here we have 0, then we have minus 6 is equal to 0. So we solve the two equations. So you'll have 2x plus y is equal to negative 6. Then the other one have x plus 2y equals to positive 6. So we need to solve these two equations. So multiply by 1, multiply by 2. We'll have 2x plus y equals to negative 6. Then you have 2x plus 4y equals to 12. So what you're going to do, you're going to subtract. This will be 0. 4 minus y, you have 3y. 12 minus 6, 18. So it implies that our y is 6. If y is 6, then replacing in one of the equation, have 2x plus 6 equals to negative 6. 2x is equals to negative 12. So your x is negative 6. So you have one of your stationary point xy of negative 6, 6. Stationary point, you have negative 6, 6. So for us to determine their nature, if you want to determine the nature, it means we need to find the second derivative. We find d squared z over dx squared. So here with respect to x, we shall only find 2. Then again d squared z over dy squared. With respect to y again, this one positive 2. Then again we can also find d squared z over dx dy. So after finding with respect to x, then we also find with respect to y. We shall only have 1. So using this second derivative, we are going to use Hess determinant. We're going to use the Hess determinant, where we find zxx multiplied by zyy, and you have minus 2zx y squared. So this one will give you 2 multiplied by 2 minus 2 multiplied by 1 squared, which is 3. This one is a positive value. So it means this point is a local minimum. The point is a local minimum.